John. We work at a company called Test Devices by SCHENCK. We're located pretty close to here in Hudson, Massachusetts, about 45 minutes outside of Boston. So we're going to take you through a little bit about the company and then kind of dive right into showing you what we've built. It's a lot of screenshots and little video clips. Just take you through it.
Sure. So what do we do? We're a spin testing and inspection facility that is really a value-added service for a lot of parts in the aerospace and automotive industry. Well, on the production side, we tend to get the same parts over and over, repeat, and we have a frozen locked process for those that we need to adhere to, and we can get into more of that later. There's a lot of aerospace requirements that we need to be beholden to, ITAR, all of that. Full traceability, document control, record keeping, all things that Tulip has helped us implement and keep track of in a way that you could do on paper, and we were doing on paper, but it's significantly transformed now that it's all in Tulip.
So when we originally started going down this path of migrating to Tulip or implementing Tulip, we really just had kind of one goal in mind: just get rid of our paper work instructions, which is pretty familiar to a lot of people in the binder, get rid of paper travelers that follow the parts around the facility. That was kind of the goal. I think it's gone further than that. We found that the more and more we've implemented, the more our team was able to get done without necessarily increasing the workforce. So, as I'm sure our sales manager Sean appreciates, we've launched more and more things in Tulip based on this graphic, so we're just going to take you through it. And I'm sorry, the very first slide of the Tulip presentation is an Excel sheet, but this is the one Excel sheet we still use, and we're looking to move to OCR or something through all the Tulip AI in the future to get rid of even this part. But we receive parts in from our vendors, they send us the parts, we do processing to them and then ship them back out. So this is the step where we're receiving them into the facility. It uploads it to Tulip through the API. Then our documentation coordinator can use this app. They're uploading all the purchase orders directly into Tulip. They're linking those purchase orders to serial numbers. It's keeping track of how many parts have been assigned to the PO, what was the quantity on the PO. It's not letting you assign extra. We do a lot of this right in Tulip. We have an ERP. We don't use it fully. It's more from our corporate office, and we have very small parts to do in that ERP. So instead, we handle it right in Tulip. This used to be the step that was very manual. This was creating the travelers for every single serial number, printing them out, bringing them out to the floor, and now it's seconds. After a lot of parts is processed, linked to a PO by this documentation coordinator, it then goes on to quality for that issuance to the floor, that contract review. They're checking to make sure all the drawings we have on file are the correct revision. They're checking all the serial numbers were typed correctly, that they align to the PO and the physical parts we received. Checking to make sure the routing, which I'll get into, of processes or operations or apps is correct, aligns to anything they've called out on the PO, that it was just selected correctly by the shipping team or the receiving team. It just takes them through step by step everything that they used to do very manually, and now it just gives it right at their fingertips. So the routing, we have tables built in Tulip with every operation listed in the sequence it's supposed to be processed through. This used to be handled by the traveler, now it's on a table in Tulip. And this routing could be dynamic based on decisions made by the operators as the process is flowing. So like in the orange column there, the grouping, if we choose to machine a part in-house or we choose to ship it to a vendor for machining, that operator decision during that one app will dictate what the next app that will load. To make approvals easier with our customers, a lot of our customers have to approve our processes. We made a separate app for each operation. It's not quite compostable. We are working to get back to compostable where possible. But this will look similar. You'll just have generic apps that will pull in all the information from tables. But then the great thing that now all the routing, all the work instructions, the traveler, if you will, is all in Tulip. We then don't need to the operator doesn't need to go say what's next. They don't have to go pick the next app. They can just scan a barcode on a part or on a pallet or search the serial number, and it tells them what's next. This has saved us countless times from a part skipping a critical step, and at some point in our process, you can't go back. So this prevents that.
So the main thing we've taken so far with Tulip, like Darren said, we're not quite at the stage of some of the much bigger presenters that presented yesterday. We're only about 35 people. We have one developer. Our main first step was really take the paper and digitize it. So we've done that, but in doing that, we've also taken advantage of a lot of the nice technical aspects in digital incorporation that you can do in Tulip that, again, we were doing most of with paper, but now it's captured, it's accessible, you can go back and trace it if you want to, and when you do want to, it's so much easier than needing to call Iron Mountain, have them ship a box back to you. That could take weeks. Everything's right at our fingertips. So some of our parts, depending on the logic, and we have a lot of bolt-on tooling for things that needs to happen before our testing that happens. Depending on what was used before, what other jobs the operators have been running, there's some interchangeable tooling that's used between different jobs. They might encounter an arbor setup that is either with or without a component. We can build branching logic in where they can pick, is it already built? Great, skip 3 steps ahead. If it's not, here's the relevant instructions for that assembly process. It just cuts down the clutter that they need to see, where before there'd be an extra 3 pages in the paper operation sheet that they just don't need to look at anymore. And in a similar vein, we may get the same part from a customer, and I don't think we mentioned this yet. We don't actually deal with any raw material. Because we're a value-add supplier, all of our parts come in serialized from customer ABC. We do what we need to do, and then we ship them back out. So we're a little bit different, again, than most of the other people you'll see that are taking some set of raw products, incorporating them into something and tracking that and pushing it through. But we may see the same component that comes in several different configurations, and that, again, based on a measurement that the operator can take, rather than them needing to do that mental check of, oh, this is the undersized one, this is the standard sized one. They can input the value, and it will automatically direct the work instructions to the appropriate set of instructions that they need to look at for that. Another nice thing we've taken a benefit of, again, is just in-process validation and checking of values that before you would still need to write these down on a traveler, but they're gone. They're not easily accessible. There's no real live feedback to an operator when you're doing the same thing over and over again. Things get repetitive. It's easy to miss steps. We can make things more attentive. You can do so much more with Tulip than you can with just a simple piece of black and white paper. Live feedback to the operator on if things are valid or not. If they're not, you lock the next button, they can't proceed. All of that stuff is things that you can't do with just a paper traveler. Darren has also worked some magic and built a bunch of nice custom widgets for us, and one that we use across a huge number of our apps is relatively simple, but it's a powerful tool. It's a number pad with built-in validation of a behind-the-scenes metric. We use this extensively in machining. We also use this in other places in our CMM documents. We have them type in key metrics. If it's in spec, if it's not in spec, we can either use that to lock progression, or in this case with machining, if you've machined a part and it's now undersized, you still want the operator to be able to complete the operation. They're not going to not finish the machining op, but it will then automatically report a non-conformance based on the logic that we've set up behind the scenes. And again, all this stuff is captured. We can look at all these values entered by the operator. I can see it from my desk. I don't need to get up and go look through a stack of 10 travelers to see, oh, have they been machining this feature undersized, or is the operator reporting 2,000s bigger than the CMM on this feature? I can just look at it from my desk. I don't need to go scour a bunch of paper and write things down. And just more examples of the things you can do in Tulip that you can't do with paper. Really making these slides more visually dense and less text dense. A lot of our operation sheets before were just line after line after line of text, 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 and that's very easy to gloss over things, very easy to miss things. You can tell someone to say, make sure the impeller is installed with the fins up. It's a lot better to show a picture with the flashing arrow. It's a lot more eye-catching. We haven't done a lot of this, but incorporating videos of things also just really emphasizes important aspects to the operators, because for us, with these being high-value aerospace parts, we have almost zero tolerance for risk and scrap, so we really want to make sure we're 100% right all of the time, and this helps us achieve that. Another way we've taken advantage of the digital environment is using real validation of actual information rather than just examples. And this is something we had in our Traveler before, where here's the sample part marking you should see, serial number ABC123, everyone's seen that before. But because all of the relevant data for this part is populated in the Tulip table behind the scenes, we can show them, here's the actual part marking you are going to be putting on the part. You can make sure it is this to the character. And that's something that wasn't really possible with paperwork instructions beforehand.
So then continue on just a little bit. In addition to just getting the metrics in digitally, it can also just do the math for us. The math we're doing is not necessarily complicated, but mistakes happen all the time. And you typically won't detect that mistake if the math was just done on paper incorrectly. So in here, they're using a swing gauge. They're typing in the difference from the nominal measurement, and it's just calculating out what is that diameter of this rotor. And then furthermore, it's forcing them to select if that's negative or positive. It's not going to let them type in the number unless they've selected that negative or positive. So just adding in some error proofing. And then this looks the same, but if you were to continue on, if every measurement had been green, it was in tolerance, it allows you to sign off and complete the operation. If instead any of these metrics were out of tolerance, it has that pop-up telling you to continue, and it reports the non-conformance at the end. And I must have missed it already.
I think they cut off.
Or it cut off the video.
There's supposed to be a big red button that says automatic non-conformance.
But so they will automatically do a non-conformance report, which John will get into a little bit later, what that workflow looks like. I think it cut off the video though, but they cannot proceed. It quarantines the part. Physically we move it somewhere else, but electronically it's quarantined and it cannot proceed until it's either resolved by engineering or quality, or potentially shipped back to the customer.
Mm-hmm. So this is my happy place that I live in a lot, is the non-conformance suite that Darren's built. Anytime there's a non-conformance on any part in the building that's in Tulip, I get an email automatically. There's a lot of routine minor out of tolerance on something from machining by a 10,000th of an inch. It's a feature our tooling doesn't touch. Great, our customer knows that that happens sometimes. That's expected. There's no concern for our processing. Override it, it can go back into the flow, and I can do that in under 40 seconds. That's so much better than having it get dragged across the building to quality hold, have to go look at the paper, sign something off, tell someone, inform them that, oh, you can go pull part number 234 out of there and put it back into the flow. It really streamlined that. If there's more important things that need to get looked at, I have all my reference documents here, all the customer prints, all of our internal tooling prints, the PO, everything is accessible in all these buttons he's put on the bottom. That's a huge benefit to me. I try to get everyone else in the building to look at that because knowledge is power, but they don't always want to. If something needs to be escalated above me, if I look at it and I determine, oh, there's a serious damage to this part, whether internal or external, that's nothing I can resolve. I can escalate it directly in here from my queue to our quality manager's queue. It gets pulled out of my queue. I can still look at the full list of all NC parts if I want to, but if it's out of my hair and onto someone else's plate, it minimizes what the clutter is in my area. And then again, automatically emails from automations and passes that on up the chain. When I go to resolve things, I can send it back to the flow it's currently going in. I can go back to the previous step, have them repeat that. We can go even farther back and say, oh no, someone clearly missed something 3 steps ago. Send it all the way back to before that. Something we haven't quite implemented yet is a more dynamic rework system, because with the way we have to lock our process, there's a lot of interwoven web when it comes to non-conformances and having to reinsert parts archive metrics that have been taken. If we need to redo an app, it requires the operator to re-enter things. They may not have access to those numbers anymore. So that's on our roadmap for something. But as what we have now is already so much better than what we had before, because again, it's all documented. There's a full traceability for this part on its path through our facility. It got to step 3, it had to go back to step 2 for X reason that I've documented in here. Here's the archived metric from before, the machinist remachined it. Here's the new value, oh, that's conforming, great, okay, it can keep moving.
So in addition to the tremendous administrative savings just from not having to print the paper or generate the paper, print it, fill it out, scan it in, all that, the quality reviews at the end have also seen some tremendous savings in time. So this is an example of one of our final quality check apps that's checking every required parameter for a specific process before it's released for shipment. So all the boxes along the bottom, those represent different categories of items that need to be verified by quality. And when the video started, most of them are already green, and you might not be able to tell, but they say auto. A lot of them say auto. Tulip is automatically completing those checks. It's either verifying tables or completion records or anything and everything at its disposal. The last few that it's not doing, like in this case, it's part marking. Maybe OCR could help us with this. It is handwritten in some cases, so we'll see how well that works. But the point that most of this could be automatically verified within Tulip is saving quality a tremendous amount of time. And even if they do have to verify it, it's presented to them all the information they need, what was required, what actually happened. And then there's, under that More button, they can report that non-conformance, get it onto rework steps if something was missed. This is an example right on the screen there. That was OCR reading an inspection PDF, comparing that to what was already in Tulip. If it aligns, it's all green, and it allows the part to continue. Once you get past all those verifications, assuming they were all green, it allows you to move on to just generating that CFC. Generates it right in Tulip. We were printing it in the beginning because customers wanted that printout. We've now convinced most of them that either an email or an upload to their supplier portal for us is more acceptable. So it generates it here, we save it as a PDF, and then we do whatever we need to do with that. But it's filled out with specific information from the process, any measurements that they care about, in our case, spin testing, so speed, how long we dwelled at that speed. We do some balancing, that might be included in here. Relevant drawings that were on file at the time we released these parts to the floor for processing. It's all dynamic, and we don't have to type it in there, we don't have to maintain it. It's all maintained throughout Tulip in the different apps.
And I guess one more thing on that. One of my pet peeves with paper documentation is the tailing ends of when you have, for us, say the critical spin speed of a part. That may show up in 6 or 7 different places. If there's an update from the customer, you need to remember where all those 6 or 7 places are, and if you forget to update one, that causes immense confusion and non-conformance and audit issues later. If it's all stored in a Tulip table, you update it in one place, it auto-populates and revises everywhere it needs to. That's a huge benefit. So another place we've made extensive use of Tulip and digitizing and the network capability of things is with our Calibrated Tools. Our spin pits have a large number of sensors, transducers, vibration monitors, all those type of things. Those are static, but they're still calibrated, and we keep all those records on site. We also have a huge number of hand tools, calipers, micrometers, bore gauges, et cetera. They're all barcode tagged, they're all numbered. All of them are scanned when needed by operators for a given machining operation or spin operation. So say the machinist needs 2 different size calipers and 1 micrometer to do part X. At the first stage of machining, it prompts him to scan all of those relevant tools. Darren has categorized them all behind the scenes. If it knows you need a 15 to 16 inch ID micrometer, that's exactly what you have to scan. If you scan a 17 to 18 inch ID mic and you say, oh, I can just put a different extension on it, this will say, no, you can't use that. And that yellow pop-up there, I don't know if it was too small. If you try to scan a tool that has gone out of calibration, which I'm sure no one's ever had a tech use a tool that's been out of cal by a year and said, oh, I thought that was this year. That's essentially been eliminated, because if they try to scan that tool, it will automatically, 1, notify them and send an email to quality telling them, here's the exact tool that you need to go pull off the floor, someone tried to use it. So this, again, for traceability, are requirements by our customers. On the completion record, the fact that this exact tool on this date with this CalCert is all saved, tied to serial number 123 in perpetuity, and we can go pull that back up. If we need to rerun the machining app, all of that gets archived. If they scan different tools the second time, those are uploaded. So from a traceability standpoint, again, before you're relying on your operators to write down on a paper list that they used these 7 different tools, they were probably just writing the same tools every day, whether they meant to or not. This at least facilitates them doing it properly, makes it much easier for them. They just have to scan.
So probably for sake of time, probably skip through these last 2 screenshots, but Factory File is just a quick app that we made so we could pull up all of those records. The final quality check presented it to you, but then going forward or throughout the process, you can easily pull up any of the records in that app. But just to save some time for questions, I won't go too much detail into that. Looking for the future, right? The next big thing for us is, and that's not Tulip either, that's an HMI system we're going to be using, but the point is we're going to be linking it to Tulip. Tulip will have the master data for our spin test parameters. Tulip will load that part, load the work instructions, how to load it in the spin rig, and then it will send these parameters to the HMI, to our PLCs to run the test for us. And ideally, we'll get to the point where it's semi-automated. So this is where we're going next. We're actively developing that, just a rendering what we're working on. But then once the test is done, it can then bring the results for the test right back into Tulip. You don't have to key enter anymore, the speeds, the dwell times, vibrations, any of that. It will just pull that in directly from HMI. So that's a big integration we're working on. But then overall, just summarizing, right, it's massive reduction in administrative time, which this is specifically talking about that generation of the traveler in the beginning, the filling it out, the scanning it in, the sending it to Iron Mountain for storage, not even talking about paying for Iron Mountain. Aerospace, right, we have to hold on to it for 40 years or 60 years, depending on what we're working on. That's just gone. It doesn't exist anymore. The paperwork rework events, like someone missed a signature, a date and time was wrong, doesn't exist. You can't even get to quality check if someone missed a signature, right? It's a button now. And then OCR, which we are using a little bit on that quality check in that example, and we're going to be implementing more OCR, hopefully to get rid of that spreadsheet in the beginning. That's drastically reducing the time required for any individual serial number, and we're able to increase our volume without increasing the workforce we have currently. But then, so that was kind of the main goal, like I said in the beginning, was the binder of work instructions and the travelers. So we've kind of taken care of that. It was 60% of the part numbers we process are now processed through Tulip. So we have a little bit of work to go there to get to 100% or close to 100%. But we are from start to finish. After that quality check, it goes to packing, preparing the shipment, and then shipping out the door. So it's all in Tulip. It's just not every part number we process, and we're looking to get there. But in addition to all that, it's the risk reduction. Right? You can't miss a step anymore. It will not let you proceed on. They can't pick what's next. The in-process inspections, right? It's no longer just on a piece of paper. It must be within this tolerance. Don't proceed otherwise. It forces them to type in the number. It does the corrections automatically. It automatically does that non-conformance. They cannot scan that part again until that's resolved. Quarantine the part and all that. So risk reduction, I guess we find it hard to quantify that, and that's something we're working on, getting more KPIs and quantifying what that even means. But it's just obvious looking at it for the people like doing the process day in, day out, that our risk is much more controlled now than it was before. But I mean, with that, we got like 4 minutes. If there's any questions, we just went through a ton of stuff, so I thought it'd be interesting to show what we're working on. Any questions?
So a couple things. So it seems like you worked out most of the things after the beginning of the process. At incoming, you get a part on a piece of paper, right? And somebody's still verifying information on a piece of paper, and it's feeding it to Tulip, or you're using OCR to go into Tulip. How is that working?
So we use, for our CMM machines, we're still getting a PDF of the inspection report. We don't have an integration between CMM and Tulip. We don't have an integration between our data acquisition software on the spin rigs and Tulip. So because of that, yes, there's still paper or PDFs being used, and we're using OCR to read those, in addition to have the operator type the info in right now, but future integrations might fix that.
I was referring to the incoming, when you receive the parts from the customer.
Sorry. So we're receiving, it's all paper, it's packing lists, some purchase orders include serial numbers and all that, and we are just typing it in right now. We're not using
So the peer review is still manual, you still have, okay.
The paper's gone after we enter it gets shredded, but we are using the paper and manually typing it into that spreadsheet.
And then on the back end, the OCR check that you reference, is that referencing against that original customer purchase order?
No.
Or what you hand entered in the document?
The OCR checks we're doing now are comparing against the inspection reports or in-process inspections that happened. We're not doing any OCR in the inbound paperwork. It's so inconsistent that it's certainly doable. I think pretty much everything is typically doable. We just haven't focused on that yet to deal with the inconsistencies of that inbound paperwork.
Yeah, we kind of worked from the Oreo cookie of our company. We've worked from the middle out to the edges, and shipping is the bookend. That's still, and you're not wrong, that's the most error-prone point, because that is still really the only place where there is pseudo-uncontrolled manual entry that has to go on. And that is, like Darren said, that's on the top of our list of next things to tackle. Just because every customer has a different receiver, bill of lading, all that stuff is different. That was a lot more of a task to try to get that standardized, and our shipment volumes can vary a lot. We might get a shipment of one part, we might get a shipment of 20 parts. The paperwork from one company lists all serial numbers in one way, a different one does it. Each serial number is tied to a separate forging number, then those are all listed somewhere. So again, it's all doable, we just haven't gotten to that tip of the iceberg yet.
How complex was your process for developing these travelers? Did you put these travelers together manually, or did you use OEMs and SOPs to build these travelers with the help of Tulip by using some AI? And how many travelers do you have every year, or any sense on that quantity?
So we had existing processes. Travelers already existed, work instructions already existed. Quantity, we're talking, 75 to 100 that we're considering, every year we're touching those processes. We did take this as an opportunity to revisit those work instructions. If we're already converting them, we might as well actually look a little deeper and see if we should be making updates, checking with the operators to see what they're actually doing, if it aligns, if we should change the process or should re-educate them that they're not following the process. But they did already exist. Our supplier, our customers that hire us, they specify all the tolerances. They specify quite a bit for us, but they do not provide like the work instructions. They more specify, we're going to give you this, we want this back, kind of thing.
So in the interest of time, we'll end here, but let's take a moment to give a round of applause to Darren and John.